Afternoon, everybody. Welcome to day 2 of this special course on GIS for supply chain management. My name is Prasun K Gupta. I am with the Geoinformatics department here at the Indian Institute of Remote Sensing at Dehradun. So before we start today's session, there is some housekeeping. There is small change in the schedule. The updated schedule is hopefully displayed on your screen. So there's a small change. The use case which was supposed to happen at 4:30 today has been preponed, and some of the lectures have been rescheduled. That is point one, and point two is the deck. That is, this presentation is available at this link. If you wish, you want to note it down, you can do that. That is bit.ly/scm-IIRS. There are some interesting links at the end of the slide, which may be useful to you. So you can get these slides at this link, and also some of the important information that you would like to use. So this presentation, this demonstration basically sets tone for the entire set of lectures that are meant to follow. We will talk about an end-to-end. So the learning objective is basically to understand end-to-end application of geospatial technologies on supply chain management using an open source GIS software, which is QGIS. So when we talk about geospatial technology, we are talking about all the three things: remote sensing, GIS, as well as GNSS. That is what you would commonly call the GPS. So we will touch upon all these three a little bit, and we will see how we can integrate all this in an open source software which is available technically free of cost, and how you can model your supply chain right from the raw material to the end consumers and the entire network. At the end of the lecture, you should be able to appreciate how to manage the GIS data. Of course, it is very difficult to learn the entire thing, but I will give you pointers on how you can learn in detail about this technology. Different GIS operations, some of them obviously. There are a gamut of GIS applications. You will see you will see me perform some of them, and you will be able to appreciate that there are this technology which you can use for your supply chain, and basically using this data, solve your business problem or model a scenario and try to solve it using GIS. So what is geospatial technology? Geospatial technology is basically a merger or a basket of three main technologies. One is what we call as remote sensing. You will find a lot of good content on remote sensing on our YouTube channel, on our website. Also, there are different distance learning programs we run on each of these technologies. So remote sensing is about taking images from satellites, from aerial platforms like aeroplanes or UAV platforms. So basically taking images of the Earth from a distance and then trying to gain or extract information out of it. So we will see some of the remote sensing images and how we can use it for our purposes. Then GNSS, which is Global Navigation Satellite System. India has its own GNSS system called NAVIC. Then there is IRNSS. Then the US constellation is called GPS. The Russian constellation is called GLONASS, and so on. So these constellation of satellites, or you could say set of satellites, are basically determining your position. If you have a receiver in your hand, these days the receivers are are embedded in your own mobile phones. Earlier you had to purchase a handheld receiver. If you are happy with coarse data, as in data with some amount of inaccuracy, let's say if the coordinate comes to you with 1 meter or 5 meters of error, if you're happy with it, then your mobile phone is also enough. Otherwise, you could buy different handheld receivers or backpack based, or even the ones which are used in surveying, precision surveying, like this DGPS, differential GPS and all that, which will give you up to millimeter accuracy, as I understand. So that is another set of technology. And finally, we have GIS, that is the GIS software. In fact, Dr. Samir yesterday talked in detail about the capabilities of GIS, and my colleagues in the further lectures will also talk about what are the capabilities of GIS, how you can digitize your entire supply chain in GIS, how you can perform spatial, non-spatial queries or analysis, then also perform network-based analysis and visualizations on the GIS platform. So GIS is also an amalgamation of different technologies. The GIS software itself, then these days, as you know, Python programming language is very popular. So GIS is also using a lot of Python. There are several Python packages which help you do remote sensing GIS work. That is so basically information technology, lot of programming, databases, or data mining, lot of these technologies go into GIS. Nowadays, GIS is also becoming cloud enabled. You'll find instances of GIS software enabled virtual machines available on Amazon Cloud and so on, or AWS. And then IoT, mobile apps. So these are different things which are part of the GIS domain. So in today's session, we will see how we can add raster images. Now, there are two data types. I think one of my colleagues will also talk about little bit about data types in GIS. So there are primarily two types of data. One is called rasters, one is called vectors. Rasters are basically your images, and it need not be only images from the satellites. It could be images or data sets which are in form of pixels. For example, you would be interested in knowing that there is a data set which is basically population in form of pixels. So each pixel tells you the number of people living in that pixel. That pixel is roughly about 100 meters by 100 meters. So in each pixel, how many people are living, that kind of information is also available in the public domain. Everything that you see here today that I'll show you, the software, the data sets, the code, everything is on the public domain, and 90% is open source, as in the source code is also available. So you can freely hack it and open it up and change it according to your requirements. So we will see how to add some of the raster images. Some of them was from satellites, some of them which are made or derived from several different sources and are stored as raster images. The next, how to find or how to symbolize it appropriately. So basically you have different types of data, and GIS, what it does, if it is a data set with a single band. Now, I don't want to go into details of remote sensing, but there's a single data set which is like pixels, then it interprets it like a grayscale image. You all understand grayscale images from black to white, black being the lowest value, white being the highest value. But a lot of these GIS or remote sensing or geospatial data is, you can extract information from it just by symbolizing it correctly. So we'll take DEM as an example, and we'll see DEM stands for digital elevation model. So if there is an image which tells for each pixel what is the height of the pixel. So that is another interesting information that you can add to GIS and find out for your business case use scenario whether you can utilize elevation data or maybe slope data. A lot of for example, you are into tea plantations and stuff like that, and you are interested in the slope of the land, or any industry for that matter, may it be laying pipelines, may it be everybody is interested in elevation information. From that, you can derive secondary and tertiary products like slope and aspect and so on. So that kind of data can be added to GIS, and we will see how to use some of that. How to perform raster calculations. So there is something called the raster calculator where you can basically do pixel-wise mathematics. You can add them, you can apply some a trigonometric function or some sort of calculation to derive new products. So all that can be done in GIS and basically find actionable insights for individual regions. You can use all this data and come up with some parameter or some value which helps you make a decision for your region. Next, we'll see a little bit about GNSS. We will see how you can add the data that you have captured from your GPS receiver to GIS. Okay, we will see a very simple use case. For example, let's say you have your mobile. All of you can go to the App Store and just search for GPS. There's one common app which is very widely used called GPS Tools, which if you turn on your location and your data, you can see the latitude, longitude of where you're standing. So you can take your mobile phone and go around your important asset locations, note down the coordinates in an Excel sheet, and we'll see how to add that Excel sheet into GIS, how to convert those points into a shape file and then do further analysis using that. Okay, so that is one thing that I want to show today, how to add GPS data into GIS. Of course, the GPS itself, if you have a proper GPS handle device from Magellan or Leica or all these companies, they are storing data in a format which can be directly downloaded into a laptop or your computer using a USB cable. And that file itself can be added, but if in case you do not have that GPS receiver, you can simply use your mobile phone. Then there are different things like geocoding, reverse geocoding. Some of my faculty who follow, some of the faculty, that is my colleagues, will also tell about these geocoding of addresses. Also, interestingly, all these digital cameras, your mobile phones nowadays are geotagging photographs. That is when I think Google Photos already does it for you. If you are geotagging your photographs, if you have that option enabled and you're uploading your photos to Google Photos, it will show you a map of where the photographs are taken. The same thing can be done in GIS. You can take your photos, add it to the software, convert them like points. This can be used for various use case scenarios. You want to monitor progress of a facility which is under construction. You take a geotag photograph, so it has your latitude, longitude, it has your date and time of capture, and the photograph giving you evidence of all the three together in a single place. So wide variety of use cases. Your business problem can get solved by any of these things which I'm talking about. Just have to think how to use this. We will also see a little bit about how to create your data, that is digitizing your own assets. How do I query my data? If I have lots and lots of data, a lot of data is available freely today in either rasters or vectors. How do I query my data? How do I find out data set which meets my attribute requirements, which meets my requirements that I have, like an SQL query maybe? So can I fire SQL queries on GIS? Yes, you can, in a slightly different way, but yes, you can. How do I spatially analyze my data? We'll see how we can create buffers, how we can do zonal statistics, all these different things in GIS. And how can I perform network function? Finally, at the end of the whole thing, I want to do is basically route my product from point A to point B with minimum or shortest distance or minimum time and all that. So we will see how to do that in GIS. All this we are going to show today in the free and open source software called QGIS. Also, this is there are a gamut of GIS softwares which is available in the free and open source domain. They have all different. They all support international standards like OGC and ISO, and there's a full stack available. Whether it be for your mobile device, whether it be for your desktop, whether it be for your web, your database, your programming language, it doesn't matter. There is a free and open source facility available. These have different types of capabilities. You can decimate your data on the web. You can process it on your desktop. You can use your mobile also for data collection. Look up something called ODK or GeoODK. You can do 3D visualizations. You can do modeling. Today, the need of the hour is I should be able to model my risks in my supply chain. I know my supply chain like the back of my hand, but I do not know what will be the disruption to my business if one of the components or more components fail, if my network fails, if one of my suppliers fail, if one of my manufacturing facilities fail. I should be able to model the damage. I should be able to ready for that damage, and I should have alternate paths ready for me. So first you need to know what are your points of failures, then find out what are your systems which are going to get affected and what are the alternative measures. So all this kind of be done on GIS softwares. These softwares are not made in dark dungeons by only hackers. These are usable, or these are suitable for professional people who are working in this domain, including for cartography and for making decision support systems. It is safe, it is stable, it is an open source software, so you can just rip apart the source code, find out whether there are any privacy violations happening, whether they need it. It works offline. You do not need internet. Plug out your network connection if you are scared about your data getting lost, and it works. There is no programming language required. Of course, a lot of you are from the industry. A lot of you have dev people who are capable of doing it, but at the end of the day, as managers, probably you do not need programming language to use this software, and it is compatible with all other softwares. So we will see how to model parts of it. There are several types of tools available in the software. You could find out different clusters. You could find out distances to the nearest facility, clustering, nearest neighbor analysis, overlap analysis. Main part is the main part of the GIS is QGIS for supply chain is network analysis. So you can find out service area, shortest path. There are different plugins which help you do it. There's one optimum routing tools or ORS tools which help you find directions, isochrones. How much distance can you travel in 5 minutes, 10 minutes in form of contour lines? Those are called isochrones. Then there's a QNeat plugin. A lot of content is available on the internet, on YouTube, and also I'll try to cover some of it today. So of course, QGIS is a very, very big software, and it's open source, and there is a lot to learn. So there are a set of 3 videos which are there on this link, along with the sample data sets, which was delivered on this platform itself a few years back. So you can go to this link, and there are further links to my videos and the data that I'm going to use in my videos to learn QGIS. Today's data, what we are going to see, a lot of it, especially the raster data, has been downloaded from a tool called Google Earth Engine. you need to write some script. So that script I have also given to you. This is the link where you can download the script. And if you want to learn Earth Engine, there are 2 videos which have about 20,000 views on YouTube, and the links are given here. So this slide deck, as I told you, is available. Also available. You can download this, refer to these links, and learn this technology in detail. So coming back, of course, this doesn't end the lecture. I am just going back and showing you the link. It is bit.ly/scm-IIRS, where you can get these slides. Coming to GIS, QGIS. So QGIS is an open source software. You can go to qgis.org and download it from this web page, qgis.org. It is available for Windows, Linux, Mac, and any other operating system. You can download it and use it free of cost. So today we are going to, this is the data that I'm going to show you. This is QGIS. Once you install it, you should see interface. Let me start from the beginning. An interface which looks like this. You have your drives listed here. This is called the table of contents, where your data goes in. This is where the map comes. This is all the processing options that you have. You can process your raster data, your vector data. You can do your network analysis. All this from this processing toolbox and different other tools available here. You want to learn QGIS in detail, there are a set of 3 videos which I've shared with you. You can learn that. For you guys, I have modeled the let's say the unorganized or the organized dairy sector in Dehradun. And let's look at all the data sets that I have prepared. Let's start with the population data, as I was telling you about. So this is the population data. So what you're seeing here is basically the Dehradun city. To give it perspective, let me start with some familiar image like Google satellite image. Okay, all of you probably seen either this OpenStreetMap or Google Satellite. All of this can be embedded in GIS. So this is the Dehradun city. You can, all of you have Google Maps on your mobile phones, and you already know what are maps, and you are already using it to find out which is the nearest restaurant, which is the best place to hang out. There is also a small option. If you take, you will see the corresponding satellite image. These satellite images are taken from various satellites revolving our Earth from different countries. We'll not go there. So this is the Dehradun city, and there is a data set which is called the population data set. You can explore this data. You can click at any point. So let's say you are interested in a specific area. You can just click on that point and you will get a value saying this is the roughly the average number of people living in this pixel. So that is about 40 in a pixel of 100 meters by 100 meters. And as you go to the center of the city, this number will increase as you go away from the city. So this symbology basically tells you how the number of people are changing. Second thing is a data set called NDVI. Now the NDVI is basically the vegetation index. Okay. Now the vegetation index talks about which of the areas are green and which of the areas are barren. So this patch that you see here, a very linearish kind of a feature, is basically a dense forest, a reserve forest, which is just south of Dehradun city. So this green patch tells you that this is forest. The city itself doesn't have much vegetation, so you have this brownish shade. So these all layer stylings have been done. These data basically tell you how green an area is. That could be used for different things. Like, for example, you're planning some sort of agriculture-based practice. You want to know where the barren lands are, where you can develop a large farm or something. So all that can be derived from this kind of data. You cannot cut forests, you cannot encroach cities, so you can possibly find out areas where you could do, just for an example, develop a large farm. Then there is a very interesting data set called night lights. Satellites are also seeing us from the night, and they can tell you where electrification is happening, where people are living. So this kind of data is available freely. This data is the this is at 500 meters. So this is the from the satellite called IIRS, from a sensor called day and night band, and it gives you basically which are the points which have light in the night. So this is the Dehradun city, this is the Rishikesh town, and then as you go south, you have Meerut, and then down to Delhi and so on. The next is the elevation data. This is the DEM, which tells us how high is every pixel. So if you go to the north towards Mussoorie, you see that the elevation is about 3,700 meters. And as you come down to the Dehradun city itself, you will see that the elevation goes down to roughly 600 odd meters. Then there is another important information that we normally use is called land cover. Some very good global data sets are available. Now I am only showing you a screenshot of Dehradun, but on my slides there is a link which takes you to the code from where this can be downloaded from. So there's a link in my slides. You can go to this link, and this will take you to Google Earth Engine. If you are new to Google Earth Engine, you'll have to create an account on that. That requires a Google account, and the code is given. You can change all you need to do, if you want for Dehradun, now you have to do nothing, just click on run. But if you want to change it for your area, Delhi, Bombay, Calcutta, anywhere, just change these coordinates, the north, the south, the east, and the west values, and you will be able to just click on this and download the data to your Google Drive. Now let me just show you one such example, because we are running really short of time. And this is a land cover data which is available from the USGS, that is United States Geological Services, and they have given all this data for free. And Google Earth Engine, what it basically does is aggregates all this data in a single place. All this data is available separately on their service provider web pages, but I'm just showing you on Earth Engine because this is a single place where you can download all this data together. So what I just did is just I run this program, I go to task, and I ran one download process, and this download takes me to my Google Drive. So this download is complete, and the data has been downloaded on my Google Drive. This land cover data is just downloaded. You can, I don't think it will preview it here because this is GIS data, and you can download it. It's very simple, small file. If your region is small, your data will be small. If you give for the whole globe, probably it will not download. There's a restriction of the amount of download. So this data I have just downloaded, and I'm adding to my GIS interface, and there you go. My land cover is available. So in a snap of your fingers, you have the data with you. The code is given to you. The software is available for free, and you just need to use it for your purpose. Similarly, precipitation data. You want to model something for a place where there is less amount of precipitation, more amount of precipitation. All that data is available freely. That can also be downloaded from the code I have given to you. So there is one thing called WorldClim precipitation. This is from a provider called WorldClim. Of course, there are different other data sets. Precipitation. Put your JavaScript guys on this, and they'll be able to help you how to improve this code for your region, for your area, and so on. Next, we'll see some of the vector data set. Now, vector data sets are basically point, lines, and polygons. Now, how do I create vector data sets? Where will I get all this data? So very simple. I'll show you. There is a text file that I had. Sorry. Or a CSV file. Just a second, guys. Right. Sorry about that. So you have your business like anything. You know where your assets are, you know their names, you have different attributes, number of people working, number of machines, what is the daily output, uh, what is the uh, number of employees, etc., etc., and you have a location for it. Yes, you have a latitude and a longitude for it in an Excel sheet. Save it like a CSV file, come to GIS, add layer, add a text delimited layer, bring that file here. So I have my dairies in Dehradun text file. I add this, specify which are your lat long columns, and that is it. Magic. You have the data that you had in Excel sheets as points in GIS. You now can do a lot of GIS stuff. You can create buffers, you can do zonal stats, you can make maps. If you want to simply make a beautiful map of these are the locations where you could go shopping, for example. So let's say this is a place where you could, I don't know, maybe have post offices, for example, or these are all the locations where you could go and drop your letters. So although this looks very blank, only you have, what about if I add roads to here? Now this is where I live, and these are the different places where I could go to drop my post. This is just an example, guys. This is just an example. You can create your own data, add your data. I showed you how to add data from an Excel sheet to GIS. And then how do I get my roads layer? This is the data that you get from OpenStreetMap. OpenStreetMap is again a volunteer project, which which basically gives open data for the entire world. There's a lot of good data, including roads, important places, available freely. My colleagues will tell you how to download the data. There are plugins here which help you download open data. So there's OpenStreetMap. Just search for OpenStreet OSM downloader, and that will help you download the street data. So okay, now we are really short of time. So let me just come back to my business question, which I was trying to answer. Now these are my dairy locations in there. These are places where okay. Now let's start from the beginning. So these are these are the different villages in Dehradun. How would I get this data? There are different places where you can get this data. First place is look up GitHub. A lot of people are putting this kind of data on GitHub. Of course, these are only uh, for like these data sets are not verified. As in, if you are interested in some data which you can legally legally, as in use, not exactly use, but so these boundaries, I would say, are generalized. You understand, generalized, like there's not exactly a curved line, but this data has been generalized. The actual boundaries are, there's only one source in the country, which is Survey of India. Of course, with the new geospatial policy, there may be some changes, but currently, if you want data which can be like said is legally correct, you can take to court and all that. is only you can get from Survey of India, but you want data to do your job and get done with it, that all is available freely on the internet. First place to search, I would suggest GitHub. This data is taken from a project which is run by NASA called SEDAC. From there, I have taken this data for Uttarakhand and then reduced it down to the Dehradun district. Now, within this district, I have a lot of good information, like what is the population of each village, what is the number of male, female, what is the main, so this is documentation of this data set, NASA Socioeconomic Data and Application Center, and lot of good variables are available for each village. What are the number of households, whether there are schools, whether there are medical facilities. So all this data is available. I have derived some information, like I have found out which, based on the population, and I have just assumed certain empirical values and found out these are the towns or these are the villages from where milk is being sourced to supply to the city of Dehradun. All this travels you from using these roads, and all this milk is collected in these villages and travels down to Dehradun, to this place which is called Achal Dairy, where the processing is done and packaging is done, and then is supplied to all these wholesalers within Dehradun, these red points that you see, which then finally reaches your home. So if I had to just find out, because we are running really short of time, what are the service area for each? You want to establish a new wholesale shop, you want to open up a new shop in Dehradun, you want to find out which is the area which is not serviced, where there is a real need for opening a shop. Find out what is the buffer around these areas. Let's say each shop caters to about 2 kilometers around it. Okay, so let's run a tool called buffer. So there's a processing algorithm called buffer, which takes this input dairies in Dehradun, finds out what is the distance. Now this is in degrees. Now we need to supply the value in kilometers. So we need 2 kilometers. Now 1 degree is roughly 100 kilometers. Roughly, just back of envelope calculations. 1 degree is roughly 100 kilometers. So if I need 2 kilometers, then I'm talking about 2 by 100, which is 0.02 degrees. Now let me add that here, 0.2, and that's it. If I run this, it should create, these are, oh, this doesn't look nice. You will say, what did sir show us? Let me dissolve these results. Oops, I didn't change the value. .02 dissolve. There you go. So this is the area which is currently being serviced by the dairies in Dehradun. Now you want to service, you have your population data with you. You know that there is a lot of areas which have high population, which is not serviced by these dairies. You know where to find, establish, or areas where you can target or do some field surveys and find out whether there is a real need. This is one kind of analysis. Obviously, a lot of other things could be done. What I want to tell you, last two things before we wind up, is how we can do network analysis. Now, network analysis is one of the most asked features. Now, what I want to do in this example is I want to show you how all this data, how all this villages using which roads the milk travels to this Achal dairy. So there is a algorithm which says shortest path. If you run this, it will ask you which is the layer representing your network, that is your road layer. You want to find the shortest path, which are the starting points. So you say my village collection centers where the milk is collected are my starting points. And what is the ending point? The ending point is this Achal Dairy right here in the center of Dehradun. And that's it. And you can obviously have different things, like you want to specify bidirectional, unidirectional roads. You can have speed limits for each road and so on, and just click on run, and it will take some time, roughly about 20 seconds, and it will highlight from each village down to the Achal Dairy what is the path taken. You can find out these paths, find out important paths, find out which paths can be used, can be amalgamated to reduce the cost incurred on transportation and so on. So different type of business decisions can be taken using this data set. I will have to stop here because there is another lecture in 5 minutes time. Oh, sorry, in 5 minutes time, and I want you guys. I want to give you guys a chance to ask questions if you have any. And this is the shortest path data which the algorithm has created. Let me just highlight it a little bit. Let me make it thicker, and you can see that it has found out from all the 270 odd villages what are the routes which are taken to transport the milk down to all these brownish layers, are showing like veins from the heart, how this milk comes down to Achal Dairy, and from here it goes to my wholesalers within the city, and then comes to my house and so on. The data set is so nice from OSM. You can also find out there is an attribute which says whether this segment of line is a bridge. Now you can fire what is known as an attribute query. I want to find out whether the bridge is equal to yes, and there you go. You have roughly, because there are a lot of seasonal streams in this region, there are roughly 633 bridges in this region, and all of them have got highlighted in this data set. And you would be surprised to see, if you add your satellite data or if you add your OpenStreet, they exactly overlap, and thereby you can find out, in case of a mishap, in case of the bridge being washed away, God forbid nothing like that happens, but in case a bridge like that gets washed away, what is the amount of milk which gets disrupted? What will be shortage created in the city? And thereon make alternate arrangements or make backup plans for your business. So this is, in summary, a very short way or very short demonstration of how you could use GIS to model your supply chain, find answers to your business queries, and probably at one day be able to model risks, model alternate supply chains, and minimize loss to your businesses. So I would like to stop here, take a very small break, maybe a few minutes, or and then come back with any questions if you have. Right. Thank you.